I'm also a speaker on several conferences. Maybe you saw me in 2012, and it was a pleasure to speak in Amsterdam, because in the Netherlands there was Techdays, for example. And I am also a trainer, MVP, blah blah blah, MCT, blah blah blah. Yeah, so all the Microsoft certifications that you've got. What is my background and why I'm standing in front of you and talking about such a boring topic like malware, for example? Because malware is something that is now #1 topic in all security lists that you've got. APT, so advanced persistent threats, that's also a hot topic. There are a couple of interesting things to say. Third thing is that if we focus about what malware is and what malware is doing, I think it's really important to understand that malware doesn't really matter if it's like written by Chinese guys. This is really hot topic as well. Doesn't really matter because operating system is very limited scope, has a very limited scope, and there's not much we can do. It's always about the same areas, the same issues, maybe in a little bit more sophisticated way, but it's all the same. So my goal standing in front of you today is to show you a couple of things related with malware. For example, we'll be playing with Stuxnet a little bit, and you're gonna get Stuxnet afterwards, and I'm really serious about it. But we're gonna also analyze the technical details, in general, what malware can do. And I will show you a couple of interesting cases of my malware as well, where malware can get and what can happen in the operating system because you got malware, yes? So this is my background. I have also access to a source code of Windows. I had a thief, don't get me wrong. I got it legally. Yeah, this is very useful if I would like to analyze a couple of things more. I'm not a developer. I swear on developers. If you're a developer, raise your hand. Oh my god. No, I'm sorry. 50% of you. Okay, just kidding, you know. So this is the background, and the session is going to be about technical details for malware. So I hope that this is something that you are expecting. First of all, contact details. So if you want to send me an email, if you want to know who I am, these are the details here. So a couple of things regarding my professional background. I have my own company that is called Secure, and I'm also partnered with a company that is called iDesign. And if you are a developer, probably you are familiar more with names like Jualo, Michole, Bustamante, Dino Esposito, and so on. So these are the guys that are as well in my team. From the security perspective and from the IT tools perspective, I'm having my own company. So these are the details. Please feel free to send me an email if at some point you will have some questions after the presentation. My goal for today is for you to become a little bit more familiar what can happen. I'm sure that everybody experienced at least one malware in a lifetime, so we'll be discussing a couple of known issues maybe for you or maybe unknown. But my simple goal for today, very simple, and I hope you're gonna make a deal with me in the morning, is that if you could pick like one technique to find out malware and implement it not only for malware, but also for research in the areas of the operating system, it would be great. Agreed? Might be like that? I'm not asking for a lot, only for a small thing, okay? Just pick one thing, one tool, maybe something that you're gonna like, remember, like it with your whole heart, and take it home, okay? So, I believe that with this kind of simple situation, work can be a little bit nicer from the malware perspective. In general. So, what we are talking about. So my agenda is usually very, very simple. A couple of malware cases to be discussed. So this is the background for the whole presentation. Then we'll be discussing about the launch and delivery of the code. So what can we expect? Why, for example, Stuxnet was such a successful thing, yes? Why Duke was successful? Why Flame was successful? So we're going to discuss technical details for that. Plus, we'll be playing with Stuxnet obviously as well, because my team, the security team, was actually analyzing Stuxnet, and I will show you all the details with you. And hiding and detecting. So if you're a developer, probably you're going to be super happy. If you're an IT pro, maybe a little bit less, but for both the depends in which areas you're going to use it. Yeah, I know debugging maybe from IT Pro side doesn't sound really appealing, but I will show you the debugging that you can do also at home if you would like to, because I will give you all the details how to do it. So that at some point, maybe that's a new subject that you're gonna jump into. Before we start everything related to this session, let me actually write one thing. So, if you do have a laptop on your knees, or if you would like to work during this session, that's definitely welcome. But as well, maybe you would like to do things that I'm doing simultaneously, and all the tools that I will be using that I can share, including Stuxnet, is in stderr.pl Techdays. Yeah, so write that down. It's a website, obviously. So enter that. Directory browsing, you will find all the details. Download the tools that I'm using and give a video, yes, so that we will get the most from the session as much as possible. Okay? So let's make it super nice and intense. Cool. So, got it? I'll be referring back to this website. Perfect. So, got the tools. Regarding Stuxnet, you must promise to me one thing. I'm asking for a lot of things in the morning, but you must promise one thing, that you will use it only for a good reason. Cool? Are we cool? Just say yes. Okay. Yes. Let's move forward. So, if you look at the map, this is actually in Taiwan, if you were wondering, from A to B. So, what is the background for all the details that are related to Stuxnet? And let's begin with that. So, you see the simple map. And if you go, and this is a walking distance, obviously, if you go from one point to another point, in the middle of the whole trip, you can also some coffee and so on. So let's say this is Taiwan, because it is Taiwan. And on one side, you've got Realtek. On another one side, you've got J-Micro. So this is this guy or lady or whoever walking, stealing a certificate from Realtek, drinking a coffee in the middle of the trip, going to J-Micro, stealing a certificate, flying to US, passing to US government. Sounds like a very nice job to do, yes? What is the point? The point of that is that Stuxnet drivers that we'll be discussing were actually signed by a legit, with legit certificates of Realtek and J-Micro, which means there is somebody else engaged in the whole process. So just a small flavor at the beginning. We are very used to the fact that we've got right now advanced persistent threats, and what's that about? If we focus about, for example, what Stuxnet was targeting, is actually at the end human beings. What Ghost was targeting? Ghost was a piece of malware that was the last out of 4. So we had Stuxnet, we've got Duco, we've got Flame, we've got Ghost, which was I would say the last one that is really, really popular, was targeting people that are in Lebanon, somebody else as well, but in vast majority of cases, there were around 2,000 hits for people in Lebanon stealing banking credentials. That never happened before. I mean, not at that scale. Stuxnet was using 4 zero-day vulnerabilities. That never happened before. So what is going on right now? Is it like a cyber war? Let me show you the technical details. Yeah? So I don't want to pass in front of you my political views, but in general, you're going to discuss what that malware was doing. Power plant, Iran, centrifuges, enriching uranium. Stuxnet was actually targeting those. So interesting thing is that there are a couple of ideas, if it's about this what Stuxnet was actually doing, is that the general idea was to technically break centrifuges, make them blow up. But the problem was, and this was a technical investigation, like what is happening in a centrifuge, is that in a centrifuge, you've got a couple of technical mechanisms that are actually not allowing the temperature and the speed to be increased. And the Stuxnet law was to be in the middle whenever the Well, I mean, the era when we had like the Pac-Man eating dots, every time we type them, it's a bit over. What is this malware to zero that we are discussing? So that's something that is actually targeting human beings, targeting our money, being a part of some cyber war, and at the same time using advanced Windows internals functionalities. It's no longer exe file that whenever we run it, oh, we got a virus. Don't run this exe file. We don't have such situations. Now we're warned. Yes? This application is not signed. Are you sure you want to run it? Well, anyway, well, that's your choice. So this is this era that we're having, is that how to create something interesting, some malware files, some technique, so that nobody will notice. It's going to use Windows operating system features. Plus, if it's like that, it's going to be perfect. It's an attack or a situation that is caused by user only. I got here USB stick. It looks like one of this cheap stuff that they give you at conferences, yes? It breaks like within a couple of months. I hope mine won't be broken. It's not actually a USB stick. It looks like a cheap USB stick, so that you think it's a cheap USB stick, yes? It's actually a keyboard. It's like, is there a keyboard? No. It actually has a keyboard's chipset. So when I plug it in to your laptop, what is my goal? To hack you, whatever it means? Maybe not necessarily that. But what my goal is going to be is to steal your data. Can I do it when you do it? Do you have access to your data? Obviously, yes. As a user, yes. I don't care about your laptop, I care about your data. If I plug it in, I say, hey, listen, can you please put me your presentation on this USB stick? And you're going to be, yeah, sure, because you're very helpful. Dutch people are helpful, obviously. So they're going to put things on my storage here. But in the background, I'm going to copy all your files. Never trust all. Yes? Okay, guys. So, what is the background for all the situations and all the situations that happen according to Stuxnet? So, as you see, and this is like a hot, maybe not the hottest news ever, but kind of hot news, is that Stuxnet was existing before we thought it was existing. Yes? So this is the version 0.5 that Symantec discovered, is that Stuxnet was before we thought it was. Yes? So what it means actually, it means that basically it was a targeted attack to Iran, yes, to power down the old power plants that were enriching uranium. And the interesting case was here that we were using Windows vulnerabilities. One of the vulnerabilities that I'm going to show you, and I will do this on Windows XP, not because it's only working on Windows XP, but because my package actually works on Windows XP. So I will show you all the details. And if you want to play with that, you need to have Windows XP as well. So the interesting case, this LNK vulnerability, was that every time I create a shortcut, so let's say you create a shortcut on your desktop to see.exe, you create a shortcut. The interesting case is that explorer.exe is loading the whole file that the shortcut is pointing to the memory. Huh? Can you imagine how stupid is that? I mean, this is so easy. Yes? So you create a shortcut, then you load it to memory. Well, cool. So if I do have files that are shortcuts, and I'm pointing to something that is malware, will this be loaded to memory? Yes. As a user, yes. Why? Because explorer.exe, it's owned by who? A user. If Winnie the Pooh is logging in, who owns explorer.exe? Winnie the Pooh. What Winnie the Pooh can do to explorer.exe? Everything. Because it's a Winnie the Pooh process. Yes? So this is the background. And there were also other spread methods regarding the Stuxnet. Here you got some details. We do have some drivers that were signed, that were in kernel mode, certificates were stolen, so apparently somebody moved to Taiwan to steal the certificates. That's like really heavy issue. I mean, normally, when you want to be like, you know, this IT geek sitting in a basement coding some malware, probably you won't fly to Taiwan because it's too expensive, too much hassle, you want to do a certificate, blah, blah, blah. So who wrote that? Was it you? Interesting. Yeah, so many people claim, obviously, that this was the US government. Yeah. And again, I don't want to make any claims here on stage. But Obama, on 2nd of June, he said, yes, we are playing Olympic Games. What are Olympic Games? Olympic Games is actually a cyber war program that is including Stuxnet as a code to target some countries. And there are a couple of areas related to that. So, read some press news from June 2012. You're going to see that really interesting and hot stuff going on. When I saw it, all my jaw was on the floor. I was like, wow, you said it? Really? Yes? Maybe he was just kidding. I don't think so. Okay, so this was the background for that, is that we had a LNK extension, and this extension was actually loading a whole bunch of code. Perfect. So what is the infection detail? What are the infection details? I will show you, of course, how something works because I do have it with me. So we do have this shortcut LNK file, which is here. Shortcut LNK file is loading these two files. One of the files, it's a loader, another part, it's a code. Then Stuxnet hides itself. There's an operating system function that is deleting a file after you close it. So it's not an immediate deletion. So this is this hiding thing. Files won't be just there. So, interesting case. And then later on, what is happening is that Stuxnet, when it loads to the memory, it replicates itself in the memory, and every time we want to run it, we run it through memory, and we're referring back to the memory. So there are no real files, except for two places that are actually running Stuxnet. You need to have some reflection on the drive, no doubt about that. It's an operating system, not a rocket science. So you need to have something that's going to keep things going. Perfect. So, let me show you the Stuxnet idea. Okay? So, for that, I will run Windows XP. And my goal for Windows XP, let me log on. And this ugly wallpaper that you've got in the back is to show you how old is that. I mean, what kind of designer could create this kind of wallpaper? It's so disgusting, yes? So I just wanted to, I set it up by purpose. It's just ugly. Okay, guys, so a couple of things. First of all, I don't have a Stuxnet right now injected, and how can I recognize it? So it's going to be very, very easy, because in here I have a process hacker, for example, in which I'm able to check out what are the sub-processes for WinLogger. WinLogger, and why actually WinLogger? Because Stuxnet, when it's injecting, it's actually creating another local security authority subsystem.exe file, and when you've got like 3 bosses in your company, it just cannot work perfectly. So in here, the only legit one is going to be this one, and in the bottom, in a moment you will see when I'm injecting Stuxnet, that's going to be another 2. And what is the purpose, what are drivers and all that stuff? Let me inject it. Okay, so let me jump into my machine. Yeah, I do have in here Stuxnet extractor. And Stuxnet extractor is actually an extractor that won't be recognized by your antivirus. That's why I'm saying you can have it, and it's on the Techdays folder. And that's something that is written by Michael. Michael is a developer in my team. Really interesting developer with a very limited interface, because what he does, he only writes code. You cannot really talk to him. He's so unsocial. It's like, Michael, how are you? Let's skip this shit quote, and let's move to the code. I'm like, okay, whatever. That's not really nice, but whatever. Okay, so let me put the date back, because Stuxnet is no longer working, because it expired on 24th of June, 2012. So I need to be back, and let me be back to February, okay? So, February 2012. Yep. And let me run the console then, because what I will need to do, and it's going to be a little bit more comfortable, so that's good, is to copy Stuxnet extractor to the C drive. Yes? And I can have one file copied, whatever. Yeah. Yes, CLS. There, I have Stuxnet extractor. If I run it, I have a folder created, which is the C on CD 9, whatever. So let me actually enter that, 9. And in here, you got exactly the files that I was describing. Yes? So one is, as you see, the LNK file. It's the one that's going to load this guy first, because it's smaller, it's a loader, and this loader is going to load the real Stuxnet code. And it's a real Stuxnet, the one, yes? This was the first injection method, by the way. So if you want to have fun with Stuxnet and what it does and what is the effect, I don't have a whole seminar about it, so let me just show you how it works, and let's don't go into very much details regarding memory analysis. I will tell you what is happening when we inject it. So this is the scenario. Okay, guys. So let me switch to a process hacker here, and what you're going to see are two new processes that are created here when I inject Stuxnet. And to be able to inject it, the only thing we need to do is to open that folder. Because as I said, explore.exe is loading shortcut, that is loading loader, that is loading Stuxnet. So this is this explore LNK vulnerability. Are you focused? Yes?
Yep.
Yes? Yes. Okay, so it's going to be very, very short. It's going to be like blink. So, 3, 2, 1. You saw that? Fast blink. And they're no longer there. Stuxnet is loaded. Perfect. So now, what we need to do, we need to wait. You see the green process. This is lsass.exe being created. And lsass.exe, it's always a sub-process, a child process of Winogo. It cannot be differently. As you see, there is a little bit more processes loading, and this is the whole Stuxnet case. So they're going to be gone. One of them is going to be gone. So we're going to have 2, as you see. And then the interesting case is that this is it. But Stuxnet also creates something that is called operating system service. And if it's about who manages all this stuff, is service and its driver. Can we see the service in services.msc? No. Why not? Because, let me actually show you this one. Is it going to be a little bit more comfortable? No difference at all. No. Reg edit. We cannot see the service that Stuxnet is using because if you go to services, so I am right now in registry editor, local machine, system, current control set. I will expand services, and the answer is because some of the services, so let me move to meet, are starting with a value 0 or 1. Start 0 or 1. Stuxnet is starting with value 1. These services are hidden from your eyes. What's more, these types of services are even hidden from most of the tools that are listing services. Which means that these services are not the ones that should be modified. And whenever you are starting the service, whenever the service is starting with a value 0, either 1, 0 means boot. So during the booting phase, so drivers, for example, for your hard drive. Yes? So first we've got a hard drive, then we've got drivers for NTFS.sys, for example. So this is number 1. So 0, 1. You won't see this, never ever. And this is how Stuxnet was operated, by the service that it was hidden. And you were like, okay, what do I have in my services at MSC? Well, nothing, because service at MSC is not at some point you would like to disable processing group policy on your computer, you just boot up, connect the registry in offline mode, and you change it to 4. And then no settings are processed. This is a perfect method to turn off AppLocker. I haven't said anything. So, let me move out. So as you see, we do have a couple of things additionally loaded. Cool. So this is the whole idea if we're discussing the Stuxnet. One more thing. I will run Tools Explorer. It doesn't really matter what kind of tool you run. But what I would like to show you, view, lower pane view, ELS. It's a little bit more comfortable. When I go to System, let me first go to that point, and I will enlarge you all the details. Yes, we got it. This is the case. So we've got here a bunch of drivers that are actually Stuxnet driver. So for example, enriching.cls.sys, it's Stuxnet, Windows NT CLS mini driver. Sounds perfectly legit. What is even more, or maybe what was even more, so let me take this CLS properties, is that when you have a look in here, it's not verified Microsoft Corporation. Yes? And if we click verify, it takes a moment, but the side effect of it, exactly, this is massive. Realtek. How can you trust Realtek? They produce network cards that are broken within 10 days. But still, it's a certificate, yes? So this is why, and this is how Stuxnet is able to run on that operating system, which is Windows 7 64-bit. Because if you're running kernel mode drivers, the only physical required for that, for the drivers to run, is to be signed whenever you are running them on 64-bit operating system, whenever you run the driver in the kernel mode. 64-bit operating system, kernel mode driver must be signed. The rest, no. You will be warned, but the driver will run. In 64-bit operating system, kernel mode driver, if the driver is not signed, you are not able to run it. The exception is debugging mode. Well then, what can I say? You will be able to run whatever. This is how developers can work on drivers. Sometimes drivers, for the first time, they're not signed, obviously. But this is the background. Okay, guys? So, let me show you a couple of technical backgrounds for malware, where we are searching for specific types of files, areas of focus, and so on. So whenever we are thinking malware, we need to think per DLL. And sincerely, what I'm planning to show you, anybody from Microsoft? Yeah. Yes. What I'm planning to show you is the vulnerability that we discovered with my developer and my husband. He's doing the same. Yesterday morning. My friends asked me to do like that. And I will of course tell you what is the mitigation. Really? Okay. So, first of all, DLLs. What is the point? The point is that whenever you are playing with DLLs in operating system does not have to be signed. Agreed? Drivers, yes. Whenever you've got application, you are notified that the application cannot run because it's outside. Awesome. But what about DLL? How can we run DLL? You need to have a mechanism that's going to load DLL. Does this mechanism check for the file signature? No. Cool. That's the perfect situation. The domain controller, and what I will simply do is actually I will reboot it. Windows I will reboot it. So restart to the Windows ISO image that I have inside this virtual machine, and I will inject DLL that's going to be loaded by lsass.exe that's going to listen to the password changes in the whole domain that you made, and it's going to send them over the network. Juicy. So this is the first my demo for today. So let me do top, and let me inject it, and let me show you side effect of it. Okay. Sorry. Yes. Come on, USB. Show me. Yes. Next. Repair. Yeah, troubleshoot. Command prompt. And then, let me actually go to full screen to be a little bit more comfortable. Rec edit. And then, I need to load the registry that is on the operating system's level, which is this, not that registry because it's a Windows PE, so file, load Hive, and then let's jump to D, Windows, and then System32, and then config. Perfect. And then what I need to do is to load a branch that is called system. Okay, blah blah blah. Doesn't really matter. And then I need to pick the appropriate control set. To be able to do that, I need to check out what is in the select key. So in select, current means number 1, which means I need to go to number 1. Or if you don't know, you can always change in both. It's a good plan. Okay, now I will go to control, and now I will go to something that is called LSA, Local Security Authority. And in Local Security Authority, I got something that is called notification package. And notification package is the package that's going to notify you every time your password is not complex enough. Yes, so who is checking for that? Well, SCECLI DLL is checking for that. Yes, but if you put here your DLL with the functionality that is called password filtering, you are able to listen to passwords. Tracking is over-advertised. Yes, let's just get it. Okay, so what I will do here, C Windows, System, and then P stands for Paula, Spy stands for Spy. Yep, I got it. P Spy and System32, of course. And then 64, DLL. 64 is to think that it's 64. It has nothing to do with 64 bits. It's just a bit. P Spy, 64 bits. Perfect. Yes, and cannot contain empty strings. Doesn't really matter because I left one line, but the file is loaded. Where do I get the file from? From the USB stick, whatever. You just load it offline. So you can come with the Windows PE, including the DLL, and you can copy this to Windows System 32. That's how I got it over there. Okay, so all set, almost all set, because I would like to show you additional case here. So let me run reg edit again, and no, this one, and let me load actually System Hive. So load Hive, software. Thinking software. Blah blah blah, more blah blahs, and yep, got it. So there is a very interesting case. If we go to Microsoft, Windows NT, and then current version, and then if we go to image file execution options, if at some point you will forget the password for your domain controller, this is how you can reset it. So what I will do, I will create new key, and I will call it userman. What is userman? On-screen keyboard, accessibility settings, and so on, yes? You got it on the Windows screen. That's what we are doing. Userman Alexi. And then, I will create new string value called debugger. And debugger of userman is going to be cmd.exe. Sounds logical? Yeah. So let's debug it. Yes? Continue. Perfect. Yeah, we're not booting anymore from cd/dvd. And yeah. So the side effect of what I just did is that A, I've loaded a DLL that's going to be working as a notification package, sending out passwords through the network. The second thing that I did, I've replaced the util-man.exe, well, not even replace, I'm debugging util-man.exe with cmd.exe. Image file execution options. It's a really interesting mechanism if you would like to execute files through other files. So it's a pretty sneaky mechanism because there is an operating system, something that is called SFC. This is a scanner for integrity of operating system files. It's not starting every time you reboot, but if you feel that operating system file was changed, you can always run SFC, verify only, and you see that util-man was changed if somebody replaces that. Well, we don't want that kind of situation. We would like to hide. So why not put things in something that is called image hijacks, image file execution options. This is a common name for it, image hijacks. So that we are able to debug things that are on the Windows screen here. This is a fact. And then you go net user, administrator, password, and because it's domain controller, it doesn't really matter because it's going to be reset and then you can add domain, and you are able to reset it. But this is just a backside of what I wanted to show you. Yeah. And of course here. But what I wanted to show you is actually how my DLL is working. This is Susanna. She's shaking all the time. So let me jump in one thing, which is going to be Wireshark. Oh. Because we are sending passwords over the net. So capture, interfaces, Microsoft, start, UDP, apply, because this is my, I'm sending passwords over UDP, port 12345, not. And what I will do, I will go to Active Directory users and computers. And then I will reset the password for Bruce Lee. Reset password, why not? Password. By the way, one more thing, ABC123, ABC123. Password complexity policy, blah, 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 blah. Notification package is sending that. You feel notified, that is not complex enough. So now we can make it complex enough. Password. Notification package, checking on the clear text. I mean, don't get me wrong, it's not a problem. We don't have much choice. If you want to know that your password is complex enough, you can't do it in hash. You need to do it somehow. And then we're able to browse through the whole UDP communication, which is not really reach. But, oh wait a minute. Bruce Lee, it's his login name. And in here, we got the Bruce Lee's password.
Yes.
Nice.
Ooh.
Okay, so this is the whole setup. Yes? Okay, guys. So now the other story. Regarding the delivery. If we're wondering what kind of methods we are picking for delivery, we can, for example, pick a method that I showed you at the beginning, which is this small keyboard. So, what to do and how it works. First of all, let me switch to a duplicated mode, because I'm going to hack myself, actually. Oh, pink. Not that I like pink. Actually, I don't. Okay, but, so let me move along. Yes, let me minimize everything. Now we're going to see the whole mess that I have on my desktop. But, what I will do, I will plug in, simply sticking this USB stick to my USB port, and then you're going to see all the things that are happening.
Already sticking.
Might be orange. Everything is better than pink. Okay, guys, so, yeah, getting there? Yes, raccoon. Yay! Perfect, so let me plug it in so that you can see all the stuff. And this is the moment that I'm really scared, delay with 7.5 seconds. So if in 7.5 seconds nothing's going to happen, then it means my network is not really working.
No.
But I'm really keeping the fingers crossed that it's going to work. Because what I'm just doing right now, I am opening myself a console. If you're admin and if you're wondering, can they bypass UAC? Well, they can. If you plug in somebody's USB stick, nobody else has the password, maybe the user. The other thing is that when I, for example, connect to my FTP server, if you're snipping right now, you will know the password, but it's a pretty limited user. And what I'm doing, I'm switching to binary mode, and I'm downloading 2 malware files. Exquisite malware, ini it's a control file. Okay? You can enter the page if you want. This update.txt is actually on Techdays that we're going to download. So, we got files. Bye-bye. Now, we're installing the service. Silently. Service is starting. Perfect. Off. This is it. You like it? Oh, yeah, of course, we can exit. I mean, you haven't seen anything. Never ever. So what is the story underneath? The story underneath is that we do have here, let me run services, MSC. We do have here very important service that is running. What is this service doing? I will switch to my domain controller. I will show you the side effect. What is this service doing on my laptop right now is asking if update.txt file is on the network. Yes? Let me show you. And if a couple of parts, they won't be there, we're going to explode things that we've got here in very important service. It's a little bit reverse attack. So, let me show you the background. This is on my domain controller. Yeah, let me go to the full screen. And I'm switching to a domain controller with a reason. Because I have here, I don't want to use my FTP server, if you understand me why, to connect for real in this network with my account. So I'm switching here, and here we've got exactly the same setup as I just did. So we do have here very important service running. So let me actually run that. CMD, services, MSC, got it. And a very important service. Let me sort by description. In the page up, sorry. Yeah. So very important service is running. And if we do some sniffing, what is this service doing? So we clear the filter right now. There is a lot of traffic going on, asking for something that is called update.txt. So, as you see, we've got here communication HTTP, okay, and you got here the query for the file that contains information that says still no updates. Let me enlarge that so that everybody can see it. Yep. Oh, wait a moment. Yeah, we've got still no updates. What kind of updates we're talking about? So my service is querying file in the web. Yes? So if I am administrator and I hate working here, I'm gonna crack you down, put you down, and in a year later, I'm gonna do something malicious. So what is the scenario? The scenario is that if we do have our web server, which might be the blog, so this is the perfect replication of what I just said, I do have here a site, default website. Let me actually explore that. So right click and explore. I do have here this update.txt that says still no updates. Let's say it's your blog. And if you're gonna remove word still on the blog, things are gonna be exploding on the other side. Who cancels the communication over HTTP from outside to the internet? You use internet? Yes? That's the case, yes? No, we're not downloading anything. Nobody is communicating with us. This is us communicating with somebody else. It's pretty hard to let me delete it. Because I lost the network communication apparently with the web server. If I refresh it, you see that the file is not really appearing. But if I, on the web server, remove word steal and save it, on the domain controller site, the file appears. Bit scary, I would say. Yeah. So this is the traffic that is going from our site, yes? And if things are not in the internet somewhere, or if I say die, then your infrastructure might die at some point. So this is the scenario, yes? Okay, so I would like to show you something even more interesting related to more malware that I have in here. But before we jump to the topic, let me switch to the slides and let me discuss a little piece of theory. And that's going to be a little bit maybe hardcore-ish because I will be doing a debugging right now. So this is the idea how we are hiding the malware from your eyes. But you will get the point what we are talking about. Okay, guys. So, regarding the launching evil code, you've noticed. Oh, I'm sorry. Come on. Yeah. You've noticed that we are able to do this through expro.exe. Stuxnet was playing with services. We were playing with some DLLs. There were some drivers. So whenever we are loading something, we need to have some instance in the operating system because things they don't load just like that. What's my goal? And this is like a part that I would like to summarize here, is that operating system is just a bunch of files. It's just a bunch of files that are working with each other under some conditions. Explore.exe is just a process. Somebody needs to start the process. So if things must be running, we need to have an instance that starts these things. Services, that's something that keeps things going. If you would like to, if you see things communicating over the network, or things are doing something, check out if it's not a driver, either if it's not a service. DLL, it's just a binary file. It's just a simple file that contains a lot of instructions inside, but it must be loaded as well by somebody. So this somebody is going to be always visible in your operating system, except for one situation. And this is something that is a bit nasty, I would say, because we do have something that is called, let me run it, active process links. What is active process links? This is a bit weird mechanism that is used to list operating system processes. And now you need to be with me because it's going to be terrible. So, let's say this speaker over here, it's Notepad. Let's say this desk, it's CMG. I am Internet Explorer. Yes? Notepad, Internet Explorer, CMD. Why these processes? Because they are the simplest ones. Yes? So, Notepad, Internet Explorer, CMD. Yeah, black one. Okay. So, if I'm in the middle, what is my next process? Come on, warm up. CMD, thank you. What is my previous process? Notepad, thank you. From the Notepad's perspective, what is the Notepad's next process? Internet Explorer. From the CMD's perspective, what is their previous process? Explorer. Perfect. So what if we make Explorer to be gone, and what if this guy is pointing that his previous process is Notepad, and Notepad's next process is CMD? Well, what's going to happen with me? I'm going to run, because there is still the process management client server admin system working on me, but nobody will be able to see me. Why like that? Because this is the only process that we've got in operating system to these processes. Why the only one? Just because. Because there's only one. And how to play with that? So first of all, let me show you, this is the only animation that I have on my presentation, and it's really breathtaking. think. What we need to do, and this is not the easy thing, but what we need to do, we need to start a debugger. Yes? And we need to be able to connect to the machine. I'm running Hyper-V, so let me show you a couple of settings that do with the machine. We need to do the debugging through the virtualized COM port. COM1, and we are specifying the name pipe, which is going to be, in our case, debug, but you may call it whatever. It doesn't really matter. But what matters is that in here, we need to specify kernel debug, and we need to set up the debug pipe. Yes? And on the machine's level, we need to reboot to the debugging mode. To do that, I'm just mentioning it, I'm not showing it. It's a BCD edit debugging. And then you set it to be on. And then you just copy and paste, if you do question mark, the default options for the connection. Just, you will see the example, just copy and paste it. Okay, so we are setting up this debug right now. And as you see, I'm waiting to reconnect. But on the virtual machine side, so let's say Windows 8, it's going to be, what I will do, I will just, simply speaking, reboot this machine. So let's say reset. Not revert, but reset, which is the previous. Yeah. And I will reboot to this debugging entry that we were discussing. And in the back, what's going to happen? See kernel debug, so I just name it like that. You may call it we need a book. That's okay. That's fine. And then, what I will be able to do, I'll be able to connect. This is the debugger that disappeared. Let me bring it back. Connect to the virtual machine. Yes? So this is the debugging session. It's not the most user-friendly thing that we could imagine. But now, I have this machine to be totally in control. Totally. I can work on that. And I can authenticate, no problem. But if at some point I will say, no, I don't want to, and this is break, I'm able to break this machine, and as you see, it's not even getting to the moment, my cursor is not even getting to the place. It's not even getting to the moment it goes to the left border. It's just hanging, waiting for my control. So if, in here, you will see that in the back. If I here press G for go, machine is back. Yes? So we are now working in a kernel mode. So this is the rootkits area. Perfect to break something, yes? So let's break something. Okay, so what I will do in that machine, I'll just do a simple setup. So let me go to the full screen to be a little more comfortable. So I'm going to run CMD. And I'm going to run Notepad. Notepad. Yes? And that's basically it. And what I'm interested in, interested in hiding Notepad from your eyes. Why Notepad? Because it's going to be hidden, but you will still see the window in front of your eyes. So this is, you will see the effect. Okay guys, so this is the whole setup that I need for my demo. And now it's time to play a little bit more with the debugger. So let me just put it like that. Close that. And what I will do, I will break so that I am in control. And in here, I will do .cmd3. So like that. cmd3. And then I will just put a path to C labs txt, lab.txt, which is a bunch of commands that I would like to pass to the machine. I won't go into details of that, but if you would like to do the same at home, or you are doing this right now, you've got the full, complete list of commands on the Techdays website. Okay, so download it and practice it. It is like days of research, even more. Anyway, this e-process structure, that's something that is not documented in details. When things are not documented in details, you want to go there. Yes? It means somebody is hiding something. Maybe there's a chance. I don't never know. It's undocumented. Okay, so let's do it. What I will do right now, I will find the process. So I'm searching for Notepad. And this debugger, which I have running locally on my machine, is saying that Notepad is available under this address in a memory. Exclamation mark process 00. 0 means for all, 0 means for very limited, it's a flag for limited information about Notepad. So list me the details about Notepad. So this is what I did. So I'm going to take this address here, Control C, and I'm going to do dot process, and then I'm going to switch myself to the context of Notepad. So everything that I'm doing is from the Notepad's perspective. What's my next one? What's my previous one? Okay. So now we can have fun because the case is, so let me display the list entry structure, is that in eProcess structure, which is the structure that is describing a process, we are able to, and pay attention to what is in the screen. This is something that is called very politely, this is a cute name, I think. Blinky blink. Yes? It's not that cute when you jump into the addresses, but the name is actually, at least that is cute here. So flink stands for forward, which is the next one. Blink stands for backwards, which is the previous one. So what is this saying right now? Is that my flink's gonna be CMD, for example. My blink's gonna be Notepad. From my perspective. Yes, that's clear? You've been with me all the time? You're not sleeping or, yeah? Cool. So guys, the next step is to set two variables so that I'm not like referring the address using some offset, but I'm setting up that my T0 variable is going to be pointing to the next process. And T1 is going to be pointing to the previous process. So that whenever I call one of those, we'll know who are those guys. Wait a moment, everything's going to become clear in a second. I'm calculating the offset. This is the C++ thing. C++ is lovely, by the way. The short off-topic story is this: I've been once on C++ party. The developers were having a party. And this C++ party was the most boring party I've ever been to. Because nobody was talking to anybody, because they were just sitting in front of the keyboard. And I'm like, what is it? And they're like, coding. It's like C++ party. And since then, when the party is boring, you just call it C++ party. No offense. No, this is just super funny. Okay, so, what is this offset? The offset is very simple. If I stand here, and I know that the speaker is over there, I know it's over there, I know where is it, I see it. But what is the distance in between us? A couple of meters? Maybe. This is offset. So that I know where is Rotterdam, I know, but what is the distance? Yes? So this is offset that I need to calculate so that I'm able to write here and here. Perfect. So I am calculating that, and I'm displaying the offset. The offset, same version of operating system. So for Windows 8, it's going to be the same for all operating systems, because this is the structure of the whole setup in operating system, right? Okay, so now the mystery is going to be revealed. What is the name of my previous process? Something. What is the name of my next process? CMD.exe. So what I did, in my machine, yes, what I did, and actually see, this is that, I would say, secret revealed, is that I was running Notepad and I was running CMD.exe. Something like that? You see? So this is this list that we're going to modify. Why this stuff is so weird? Well, apparently that's something that was running before me. Just before me, yes? But the next stuff after Notepad was CMD.exe. So let's make some deletion here. Okay. What I will do, I will just, and this is tough, so my previous flink is going to be pointing to my next one. My previous guy's forward link that is pointing originally to me is going to be pointing to my next one. Yes? My next one's link that is pointing to me is going to be pointing to this guy over here. Logical? Yeah. So let's do it. Let's make some changes. 1, 2. Let's click go. And now we can be back to the virtual machine. And I still see Notepad, which is totally fine. But if I go to Task Manager, more details. What I would like to find is Notepad. This is sorted by name, by the way. And in here, there is no Notepad.
Can you find Notepad with Process Explorer?
Once again?
Can you find Notepad with Process Explorer?
No, you can't find Notepad with Process Explorer. Because it's not the tool's problem. It's the operating system's problem. I've just modified the only mechanism that is used for listing the processes. And because it's the only one mechanism, Process Explorer is also using that. So whatever the tool you use, you won't be able to list this process.
You're in a debugger, you can do anything.
Yeah, I mean, in the debugger, that totally yes. But if you check out how most of the malware hides itself, because it's a rootkit. I'm not showing you how malware hides itself, because it won't be fancy. Forgive me, I mean, this is easy. Double click. We are rootkits. We are the rootkits. We are doing what malware is doing. We are malware right now. So we are hiding the whole stuff. I'm in the debugger to show you what malware is doing when it's a rootkit. Yes? So it's a little bit deeper. So this is the whole setup. How to find that? Well, there are like rootkit revealer tools, for example, to find that. So to compare the list of things that are considered to be processed, that are in the memory, versus what we've got in active process links. If things don't do much, then you're going to have them. Another case, I would say I like it more, is to run in debugger, exclamation mark, analyze, minus error like Richard, dump the whole memory. If you've got 60 gigabytes, that's your problem. And have a nice reading on Friday. And like, what is interesting over there? And there are, of course, memory analysis tools that can be helpful in here. But in general, that's something that is the only mechanism that you can use for hiding. So these are making the processes disappear in operating system. Yes?
But
yes.
Notepad still gets CPU time now.
Yeah,
Okay.
totally.
It's totally its own process, so it's...
I'll repeat that. So the thing is that this process that is hidden takes the CPU time. You're totally right. Because the process is still managed. What we modified, it's the stupid mechanism that is running in the back, that is displaying the processes one by one, because the slide is so beautiful. But at the same time, we've got this process managed. Yeah, it's managed totally. It has its own resources. It's working in its memory. You can refer back to it, and so on. You can kill it by process ID, because it has a process ID, but you need to know one. So you need to find it anywhere. Yes? Definitely, it's a full process that is totally running. Okay, guys. Questions afterwards, okay? Because I would like to show you one thing more. You like the idea?
Yep.
Yeah. Okay. So let me be back in here. Yes. Now the last one, the hottest one. Microsoft? Okay, so dear TXT, nothing in here. Yes, nothing in Windows. This is my local laptop, by the way. I'm running Windows. So the case is that UAC was introduced in Windows Vista, right? Right. It was introduced to Windows Vista to make sure that things are not running as an admin, so that we need to make additional effort to be able to actually do something, yes, do something more. And that's totally fine. But the window that you got with UAC usually tells you what kind of application you are running, and if it's signed, meaning known, or if it's unknown, meaning unsigned, or maybe you just don't have a trusted certificate either. Very cool. So, to my folder here. I do have here Windows folder created. It doesn't really matter what kind of name is that. I just want to show you the issue. The issue is really interesting because what can user do is that user can copy from system file from C Windows regedit.exe. User can do it. Yes? So to prove you that, what I will do, I do have here command prompt that is not elevated. Because command prompt, the regedit has manifest, it needs to be always running as an admin. It's a manifest. Always as an admin. MMC is the other example of that. But if I run cmd like that, I'm here, Paula. Yes? But if I run it obviously like that, this is manifest, run as admin. And I'm an admin. So I will do it as a Paula. Yes? So what I would like to show you is that I can do copy Windows, regedit to C Windows. And let's say Windows, which is my folder in here. Yes, I don't have regedit here yet. If I do that, one file is copied. I can copy regedit. Cool. Who can run regedit? It's a file of manifest. Regedit can be always and only run by administrator. Yes? So what is the problem? The problem is that Microsoft implemented the mechanism that is called non-DLLs. Whenever you've got non-DLLs, it means that you can load DLLs that are only from the legit source, meaning, for example, System32. But there is one exception. Whenever you've got this exception, it's always getting cooler. Okay, so you've got one exception. Yes? So this is Windows, and I do have here regedit. Yes? And remember, I had no txt files, so I can even jump it like that. Windows, dear txt files underneath. So what is possible to be done is that if I run regedit just like that, let me run it, regedit, I will type it here. You see that this is the manifest that I have, and I need to run it as an admin. I am an admin, I can, yes? But what is actually visible in here is this Microsoft Windows thing, yes? But it doesn't have to be through regedit. So this is the, let me continue. Yeah, so whatever, no. But if I have here regedit, and if I double click on it, I get the same story. But it will tell me it's unknown because it's not running from C Windows folder, from the operating system folder. But it's the same regedit. Everything is okay with regedit. But the problem is that regedit, even if it's copied somewhere else, loads the DLLs that are from the list of non-DLLs, except for one. Remember at the beginning I said that we're not checking for DLL signatures? Yes? Okay. So what I can do as a user, because it's a scenario that comes from the user side. Imagine your user is doing this. User is copying user's DLL, and I get this DLL, copying user's DLL somewhere in the folder, and copying regedit to the same folder, creating a shortcut on the desktop called regedit, calling you, maybe, or you may have your own regedit, the lazy file on the pen drive. You bring it to the problem, and then it's just enough to click yes, so that my DLL, clb.dll, it's loaded, because this DLL, it's not on the list of non-DLLs. Is regedit doing that? I just copied the legit regedit to the user's folder. User can do it. The rest of the DLLs that I don't have it are loaded legitimately from the operating system files, except for one that I'm loading, and this DLL is creating the files in safe Windows. And I totally know that maybe this demo, it's not really breathtaking, because I'm just running a file and then you got a txt file in Windows. But what just happened is that my regedit, which is the legit regedit taken from operating system, just loaded unlegit DLL. And I don't want to say what is the scenario of the attack, just use your imagination. But if the user can put a DLL somewhere, and it's going to be, for example, malware, what's going to happen? Because this is you running that, not the user. The user is just passing the DLL. I know. Yep. So, bringing the story to the end. The whole story to the end. I hope you enjoyed the session, by the way. So I hope it was interesting and fun. And I forgot to mention about one simple scenario, which is the mitigation plan. Mitigation plan is, whenever you are running operating system files, obviously they always need to be legit. I mean, our regedit was legit, but you need to always see this information. Yes? It's by Microsoft Windows. On the other hand, if you've got a legit application, not the operating system file, the legit application, and I do have this application as well, may run, so this is this one, my DLL as well. But if I open it, and if I do self-elevate, you see, but it's not an operating system file. That's why it's valid publisher secure. But if I click yes, I can load the library. So this is basically the problem that I'm mitigating here, is that whenever you're running operating system file, it's always a requirement, whenever the file is running from the other place than the legit operating system sources, you will see that it's unknown. It's an internal security mechanism. And that's fine. Pay attention to that. But if you're running third-party application, you don't have checks like that. And if the application is signed, you are able, as a user, to pass the third-party DLL, and this is you that's going to know the DLL. What kind of DLLs are those? The ones that are not on the list of known DLLs, which in this case is my DLL. If you wanna, no, this will be too late. I won't give it to you, sorry. But the mitigation method is more like paying attention to it. And I bet that Microsoft is going to patch it very, very soon. Because this DLL should never be loaded by registry. So this is the scenario. Okay, guys. So, bringing the story to the end. We discussed a couple of things regarding Stuxnet. We discussed a couple of things about how to load things in an operating system. The operating system is just a bunch of files that are working with each other. That if it's about playing with the malware research, doesn't matter if it's Stuxnet or whatever, it's always about the same areas. Because in an operating system, you don't have any other areas that may help you to run things. Services, drivers, DLLs, Explorer, legacy. These are areas that we should always pay attention to. It is a little bit painful because to list unsigned DLLs, you need to actually put additional effort to do it. For example, use autoruns, for example, use Process Explorer, and verify all signatures for all DLLs. Check out which DLLs are not signed, because there is no mechanism that is checking for that. I mean, I don't want to say it's a problem, it's a hassle, yes? It's just like that. If we're investigating that, pay attention to what kind of DLLs you're running. Because we're not checking for signatures. When you are verifying the list of drivers, it's the same situation. Check out what kind of drivers you've uploaded. Is there something that is not signed? It might be like that, because as I mentioned at the beginning, the only requirement for the driver to run in the kernel mode 64-bit operating system is the driver to be signed. The rest, so user mode 32, kernel mode 32, user mode 64, there is no requirement for signing drivers. So do the periodical check, pick the interesting method that you saw to find out where the error is.